Good evening, guys. Welcome to this masterclass. Um, Chinaza, can you hear me?
Yes, I can.
Okay. Yeah. Today we are having an interesting topic, and within the couple of minutes that we're going to spend on this call, we are going to be discussing introduction to networking in cybersecurity. Now, this masterclass is brought to us by EmbodiLearn. EmbodiLearn is a tech training company here in Nigeria. We offer training in cybersecurity and prepare individuals for a career in cybersecurity. So this masterclass is a free masterclass, and after this session, we're going to come back and discuss more about EmbodiLearn and how we can help you to become an established cybersecurity professional. So I'll leave the floor to the moderator for this session to go ahead. Chinaza, you can take the floor right now.
Good evening. Thanks for joining us today. My name is Chinaza Chibo, and I'll be your moderator for this informative webinar on Introduction to Networking in Cybersecurity. As we continue to navigate our increasingly digital world, cybersecurity has become a critical concern for individuals, organizations, and governments alike. A strong foundation in networking is essential for building robust cybersecurity measures. In this webinar, we will explore the fundamentals of networking and their applications in cybersecurity. We will discuss key concepts, traits, and best practices for securing your networks. To guide us through this important topic, I'm pleased to introduce our guest speaker, Maurice Odo. Maurice is a seasoned cybersecurity expert with extensive experience in networking, threat analysis, and incident response. He's worked with various organizations, helping them strengthen their cybersecurity measures. Maurice is passionate about sharing his knowledge and expertise with others. He's a sought after speaker, trainer, and consultant. We are fortunate today to have him with us. Without further ado, please join me in welcoming Maurice Odo.
Yeah, good evening, everyone. Please, can you hear me? The moderator, can you hear me, please? Oh,
I can hear you. I can hear you. I think, yeah, Chinaza, if you can hear him, okay, people can hear you.
okay, yeah. So, the moderator, the facilitator, the EmbodiLearn representative, has welcomed us to this informative session of introduction to networking in cybersecurity. Also, the moderator has done well to also usher us in to this session. I will be this session presenter and speaker. So the essence of this session is to help us to understand the importance, the necessity of networking in the field of cybersecurity. I believe that sometimes those who wish to go into cybersecurity just think that you can just come into the field and start doing magic, and then you're just securing things. But this security has to be done within a particular medium. So you secure networks. That is basically it. You secure networks. The way we interact with people, we do that through the network. Whether it's a SOHO, a small office or home office setting, your own personal setting. Once you want to move out of the global network to connect with people and all that, you do that through the network, through the internet. So network is basically how computers interact with each other. That's it. And when I talk about computers, I don't mean the people tend to understand computer as just a desktop. Computer is not a desktop. It's not just a desktop. Your smartwatch is a computer. Your phone is a computer. So anything that you interact with, that you use to interact with others within a medium, is called a computer. So we're going to look at introduction. We're going to introduce, because this is not going to be it's not going to be so ambiguous for us, because this is an introduction. So my main purpose within this lecture, within this masterclass, is to help to expose you on the value of networking as with regards to cybersecurity. So, and I believe at the end of this, we are also going to have question and answer sessions. So if you have questions that you would like to ask, I think we'll be there. So without wasting much of our time, I'm now going to share my screen, and then so we'll move on to what we have today. So I don't know if you can see my screen. Can you see my screen? Please, if you can see my screen,
Yeah,
please indicate.
We can see your screen.
All right. Yeah. So our topic is Introduction to Networking in Cybersecurity, the importance of networking, as we call it, the essence of knowledge of networks in the field of cybersecurity. Like I said earlier, the field of networking, the field of cybersecurity is basically built upon networking, because what you are protecting is how computers interact with each other within a network, within a particular network. Whether it's a simple network, whether it's an intranet, an internet, something global. We call internet is global. When you talk about intranet can be within a particular, within just it has to do with a small company, maybe a company, and then you have various sectors, various departments. We have the department, we have the department, we have the managerial department, we have the marketing department, sales, and so on and so forth. So how do you protect these networks? Over the course of time, we have heard that companies are being hacked. How do you protect this traffic? We use traffic to refer to the people that are making use of a particular network at a particular time, within a particular time frame. So traffics flow through a particular network. How do you curtail, how do you curb external interference within networks? How do you protect a company's assets from malicious users? We call them hackers. So that's why what you're going to do today, I want to expose you for you to understand that you cannot do cybersecurity without a good grasp of networking. If you don't know your networks, if you don't understand networks, you can't do cybersecurity. Because most of the time, what you will be doing is monitoring of networks, reading the traffic, monitoring external interference, and so on and so forth. So we're going to begin today by talking about the purpose of computer networks. Now, the reason for linking computers in a network is as important as the reason why people network. People networks are necessary to accomplish tasks that might be burdensome to be completed by a single individual. If you attended the first session we had on Zoom, where I did a sort of introduction, I told us that network is very important. When we talk about networking, understand it as communication. Understand it as communication. So what is the essence of networks? What is the essence of computer networks? It's just the reason why people also network. Why do you network? Why do various people come together to perform a particular task? So that the task will be easier to perform and so that it takes less time to complete. So if computers, imagine that in a particular enterprise, in a particular company, they only have just one computer. The manager comes and makes use of that particular computer and finishes his or her own duty. Then another person comes, the HR comes, and then performs his or her own. Then the tech person comes, performs it on the same computer. That computer will break down and it will take more time to accomplish a particular task. So that's why we chain networks, we link computers together so that the time that is taken to perform a particular task will be limited. And so it doesn't become too burdensome on one particular computer. Some people might have various computers, and one will just be for file sharing. If you move into a computer, if you move into like a cyber cafe, and then you see one computer that just sends the work of this particular computer is just to send things to be printed or something like that. And the other computer is for typing, and the other computer is for doing another thing. The other computer is for doing another one. The other computer is for receiving files, and so on and so forth. So that's the essence of networks. The essence of networks is to make sure that it takes lesser time and lesser burden for a task to be completed. Computer networks were developed to aggregate the computing power of several individual computers into initially local networks, then campus networks, then metropolitan networks, countrywide networks, and finally global networks, which we call the internet. So a network can be from your own personal home computer. We call them SOHO, small office or home office. It can also go from your local network, which is your home office, to campus networks in a particular location, a school, to metropolitan networks covering a city, to a countrywide networks covering a whole country, and then global networks, the entire globe. So that if you come today and you see that you can easily chat, interact with someone at a particular place and then at a particular time, what makes it possible is networks. Remember that I said earlier, don't understand computer as just your monitor and then your desktop and then your system units and so on and so forth. That's not just computer. Anything that you use to communicate within a particular network is known as a computer. A computer network is therefore a group of computer host devices that communicate with each other. I have mentioned this. So a computer network is a group of computers. A singular computer is a computer. But when you add one or more computers and they communicate with each other, we call them a computer network. To enable this communication, the computer host is the one that initiates the communication. The computer host devices are connected using wired or wireless communication. You know that in the world of today, you can communicate through a wired medium or through a wireless medium, like we call it Wi-Fi. But then we have wired connection, which we call the Ethernet. We call it Ethernet. ETHERNET. We call them Ethernet. So when it is wired connection, we call it Ethernet. Remember that. The communication is controlled by network software running on the computer host devices and on network devices. So the computer host, the host, like I said earlier, is the one that initiates the communication. If you want to send a particular file to someone, you as the person that wants to send is the host. The computer you are using to initiate it is the host. initiate this communication with any other devices on the network. Computer host devices can be any other devices used to access the network, including servers, workstations, personal computers, smartphones, and laptops. That's what I said earlier, that computer it's not just computer as you understand it to be, the static computer that is just there at a particular place that is immovable. Computers are also movable. Your own smartphone or smartwatch is a computer. Once it is capable of interacting with other computers, with other devices, it is a computer. Network devices can be any devices that stand between computer host devices, including switches, routers, hubs, repeaters, firewalls, and so on. Network devices control and optimize communication between host devices. So you can already see, network devices are devices that stand between the communication, there's a term we use for it. So they perform like a sort of a middleman function between networks. Now, if you come to a company, if you have gone to a company and then you tell them to show you their network rooms or where they are they are making their connections, you will see first of all whether this is a wireless or wired connection, and then you are going to see something. You're going to see things like switches. So with switches, you can connect a particular device to another. You connect multiple devices. The same thing with routers. Now, if you have ever come across a router, or okay, let me use for instance now. We all make use of our hotspots, right? Now, imagine that someone in your phone, you on your hotspot, and then first person connects to that particular network. You are the one, they are making use of your network now. Now, the first person connects to it, the second person connects, the third person connects, the fourth person connects, and so on and so forth. All these people are connected to your hotspot. So they are all in that particular network. They are all sharing that network. So under a wireless medium, we can say that the medium that is used to connect multiple hosts, multiple computer devices together are network devices. When you start going through networking proper, you are going to see switches, routers, hubs, and so on. Switches and hubs, they are almost the same thing, but switches are more brilliant than hubs. Hubs is just there, but switches though performs the function of connecting multiple computers together in a more brilliant manner. So you can compare that, and then you will see the importance of switches and then hubs in connecting networks. You can also look at routers. So how these connect with each other, the thing that helps to link a particular computer devices or to another computer device is known as a network device. Now, let's look at some network applications. Now, the first one is World Wide Web. We call it WWW. This is a network application that enables exchange of text pages coded in hypertext markup language, which we call HTML, using hypertext transfer protocol. Let me give you an instance. Let me break this down. If you want to visit a particular endpoint and you type www.embodilearn.com, what happens? You that is trying to initiate a communication, you are the host. Now, what happens at the end? What you know is that at a particular time, if it's the first time that you are visiting EmbodiLearn, you are sending a GET request. This GET request, you are sending it through a particular medium, the World Wide Web. So what happens? Immediately you send it, What happens at the back end is that you are making a GET request, and then that GET request, you are telling this particular server of EmbodiLearn to do what? Please, can you usher me into the server of EmbodiLearn? What now happens? Through this particular medium tool, through this particular network application, the server of EmbodiLearn will now give you what you need. It will give you the HTML, which is the structure upon which EmbodiLearn was built, and it will do this through a protocol known as Hypertext Transfer Protocol. Today, we have Hypertext Transfer Protocol Secure. That's the difference between HTTP and HTTPS. That's why whenever you want to visit a website and you don't see that padlock indicating that you don't see that a particular padlock in that URL, it means that that site is not secure. But once you see a padlock on that particular URL that you have visited, it means that that site is secure. So the World Wide Web is a network application through which you can interact with another computer. Electronic mail. This is a network application that allows the exchange of messages between two hosts. This is by far the most commonly used network applications. We talk about sending text messages, SMS and all that. How do you send SML? The medium through which you interact and all that. That is a network application. File transfer and file sharing. People share files. I'm just trying to tell you that there are many things that people do within a particular network. Some people might come there to just get to just access URLs, that is worldwide, through the World Wide Web. So people might come there to send text and emails and all that. So people are there to. So I'm looking at protocols because that would be an advanced topic for you. Protocols that I'm mentioning now, for instance, the World Wide Web, we talked about HTTP, HTTPS, HTML, and so on and so forth. And I think some things like RDP. And when we're talking about LMTP, IMAP, POP3, that's the protocols for sending text and receiving text. Then when we talk about file transfer and all that, we talk about FTP, SFTP, TFTP, and so on and so forth, SMB. So it is not for you to start cramming all these things. I just want to expose you. Remember, people might be in a particular network application to do what? To a get request to a particular server, and then the server computer with the necessary equipment for that particular server that they want to get. So people might be there also to send me receive. The fourth one is remote control. Remote control allows you to control a computer host remotely from another host in the network. Several remote control applications exist, such as Windows Remote Desktop, Virtual Network Computing, and Remote Share, RSH. So this is about the way people make use of, let me say, people access another person's computer through from their own end. So from your own end, you can access another person's computer. So that is remote control. Network applications, still continuing on that, we have voice over IP and video over IP, VoIP. This allows the transfer of voice and video signals over the internet protocol. Many websites stream video over the internet today. They use VoIP network applications to wrap up their video content in packets, IP packets. IP is internet protocol packets, and hand them over to the network over the network to the computer host that requested the stream video content. Now, think of what happens when you make a call over the internet, when you're making a WhatsApp call. Even the medium that we are using now, we are making use of VoIP. So I'm making a call and you can hear me through this particular medium. Each and every one of you here is listening to me and you are hearing me clearly. True or false? True. Now, this is a network application. So this particular medium we are using now is VoIP. And then when you come to a particular network, in the midst of protocols, VoIP takes precedence. The network gives its primary place. Let me give you an example. What if you want to make a call, at the same time you want to send a file to someone, at the same time you want to access somebody's computer remotely? You want to do all these things at the same time, but then the network is going to pay first attention to the VoIP, because the VoIP, that's voice over IP, that is call, whether it's voice call or video call, it needs enough network. It doesn't need interference. It doesn't want interference. So it will pay attention, okay, when I will do this one first before other ones. Even though you want to do it at the same time, it will give more attention, first attention, it will give primary place, it will give VoIP urgency than any other things that you are trying to do within that network. Shared network storage. This network application connects advanced applications to connect advanced specialized storage networks, making them accessible to any computer host connected to that network. Like I said earlier, there are applications now that enable you. That's why it is very, I advise people, know the networks that you connect to. It is not everywhere that you see Wi-Fi. They will surely say on Wi-Fi for us now, on Wi-Fi for us. You don't know how this you don't know how secure that particular network medium is. You just connect to Wi-Fi. And I tell people, whenever you are in a public place, do not connect to public Wi-Fis. Do not connect to public Wi-Fis. You as cybersecurity persons should advise people on this. Know the networks, because within a particular network, people can share and receive files. People can share and receive information. People can share and receive data. So no, a malicious hacker can just on his or her Wi-Fi, and then you connect to it, and then the person starts sending malicious packets to your device. At the end of the day, your phone is slowing down, your phone is having issues, and you don't know where it's coming from. Storage network can be either isolated, connecting only to a few computer hosts locally, or connected to other data networks. So it's either isolated. Storage networks can be either isolated when they are just connecting to in an intranet or a small office or home office. Sorry. And when they are connected to other data networks globally, or within a more inclusive position or medium, yeah, that is it. Operation flow of computer networks. A simple network can be 3 hosts connected to a hub. Remember when I mentioned about hub? Now listen carefully. Let me go again. A simple network can be 3 hosts. What did I say? It is a host. A host is a medium through which information, through which a host is a computer that communicates with other computers. So a host is a computer that is capable of communicating with other computers. A simple network can be 3 hosts connected to a hub. A hub connects hosts together. A hub connects hosts together. A hub works very much like a multiplexer or a multiple socket power bar. Hosts connect to the hub, and they can communicate with each other. Now, we can see that a host connects one or two or more network computer devices together. A hub is a network device, while the device that it is communicating with, which is a host, is a computer network. So know this when I mention this. Hosts connect to the hub and then they can communicate with each other. To initiate communication, a host needs information about another host on the network. Remember, a host is a computer network, that a host is a computer that is capable of initiating communication. So you cannot call a computer a host if it is just static and does not initiate communication. Logical IP addresses establish a connection between upper layer network protocols and applications on the host. Forget about this upper layer network. We are going to handle ISO principles today. So I think when we do that, you understand it better. Now, logical IP addresses establish a connection between upper layer network protocols and applications of the host. NIC, that's physical MAC address, establish a connection between one's network interface card and another to transmit electrical signals between NICs over the networks. Now, logical IP addresses connect. That's okay. Let me begin with MAC addresses so you understand this. So, computer A, B, C are in a particular network. Okay, computer A, host A. Let me call it host now. I'm using computer. Remember what I told you about host. A host is a computer that is capable of initiating communication. So if we have host A and host B and host C, and they are connected together by a hub or a switch, if they are connected together by a switch, they are all in that network. They are all in that network. Okay. Now, host D, host E, and host F are connected to another hub. If host A or B or C wants to connect with host D or E or F, which is another network connected to another hub, they have to do what? They have to communicate using their IP addresses. But if they want to communicate to each other within the same network, what they need is only their MAC address, their physical MAC address. But if they want to connect to an external network, which are hosts DEF, then they need their IP addresses. I don't know if you can get me. Let me come again. Now, I gave an instance that host ABC are on the same network. They are connected to a particular hub. On another network, we have host DEF. They are connected to another hub on a different network. What if host D wants to communicate with host A, which is on another network? Host D will do what? Host D needs to do what? To communicate its IP address to host A, which is on another network. But if host A wants to communicate with host B, both of them are on the same network. Host A does not need to advertise its IP address. What it needs is what? Is MAC address, is physical MAC address. So that is how computer networks flow. That is the operation flow of computer networks. Networking concepts. A collision domain is a logical network are sharing the and they can potentially send frames on the wire at the same time. So I told you that when multiple hosts are connected within a particular network, they all might be performing various duties at the same time. Host A might be sharing files, host B might be making voice the other host might be sharing files. So what happens? What happens if it is a hub? Because they all are trying to do this at the same time. They are trying to communicate at the same time. Okay, this one is trying to make a call to this particular one, and this one is trying to share a file to this particular one at the same time. So what now happens? What happens is that they will experience what we call a collision. They will collide. Networks will collide. Those frames that they are trying to pass across will collide. And then a collision domain will do what? It will experience the medium will experience a collision domain because there are multiple hosts trying to do what? To communicate at the same time. So that is the downside of hubs. So hubs does not know when to pause this host A from doing this one, and does not know when to pause host B. It will just allow every host to be doing the same thing at the same time. But that is where a switch is better. So know the difference between a switch and a hub. They perform the same duty, but a switch is more intelligent. A switch knows how to prevent a collision domain so that it might tell this one, okay, pause, let this one finish sending before you start sending. So that is what we call a collision domain. When multiple computer hosts are trying to send frames, of packet at the same time. It is best to segment network into several smaller collision domains to reduce the chances of having frame collisions. So you might not know how to segment networks now till you go deep into networking. A repeater is a hub that not only sends the frame to all ports other than the originating port, but also amplifies the electric signal. Amplifying the electric signal allows the hub to send over larger distances. So a repeater, what does a repeater do? What a repeater does is this. A repeater is a type of hub. Do you understand? A repeater connects host devices together. But a repeater tries to amplify the signal through which the distances through which this communication happens, so that it limits collision domains. So if there is enough space to share frames, then the possibility of collision domains happening will be little. The chances of it happening will be cheaper or little or lesser. Bandwidth is the maximum amount of information that can be transmitted on a transmission medium. So every information that you are passing across, that is, it is passed across in bits per second. So bandwidth is the maximum amount of information that can be transmitted on a transmission medium. So if what you are sending exceeds the particular bandwidth, then it will tell you that so and so happens that you have exceeded the particular bandwidth or something like that. So this particular thing cannot send. A switch is smarter and more expensive than a hub. It learns about devices that sends frames into the switch. A switch builds a MAC address table that lists the MAC address of the host device that is sending on each port. Whenever a frame enters the switch looks at the destination MAC address of the frame. So what happens? So you can see how switch is smarter than a hub. So what a switch does is that, remember what I told you about MAC address and IP address. If you can remember, a MAC address is the physical MAC address that connects devices within a particular network. But when a network on a particular network, when a host on a particular network wants to associate with a host on another network, it needs its IP address. So what happens if a switch collisions domain occur because a particular host is trying to initiate communication to another host on that same network? So how does switch curtail this collision domain? A switch curtails this by doing what? By preparing a MAC address table which lists the MAC address of each and every one of those host devices that is in that network. So that when this one is trying to send a particular information to another one, it is going to look, okay, is this one free to send? Is this one free to receive before it sends? If the other one is sending, then it will wait till it is doing what? Till it is free to receive before it sends. So that is how a switch does what? That is how a switch limits collision domains. So you should know the difference. A hub is a multiplex connection device. All devices connected to a hub can send frames to all other devices connected to the hub. A hub sends frames it receives on all the ports. Can you see that now? So a hub does not even want to know whether this particular host device is sending or whether it is free to receive something. It will just send it. It will send that particular information to all the ports. That's to all the host devices. So it will send it, and then you will see this one wants to send to a hub. Will still send anything that the hub sees. It will send. So it does not want to know whether this one is free or not, whether this particular port is free or not. It will just send it. So that's why a hub, even though that a hub is inexpensive, but still, you should get it. You should think of a switch. Most companies use switches because switches help. Even though as you progress, you will see other ways to segment networks, but you should just get a switch. It is better. A bridge works similar to a switch, except that it uses software instead of a hardware application-specific internet circuit, integration circuit. So a bridge too, as you progress in your networking, you are going to learn about bridges. Bridges is like a bridge is makes use of software to achieve this goal, while a switch is a hardware. So a bridge is a software that you can integrate, while a switch is you purchase switches. Switch is a hardware. So consequently, it is lower and less expensive than a switch. That is it for a bridge. So these are mediums through which what happens. These are mediums through which communicate with each other, and we call them network devices. I mentioned a hub, I mentioned repeater. So a repeater is a type of a hub. And then I mentioned bridge. Bridge is like a software specific type of switch. So know about hubs and then switches, very important. So now we look at topologies of computer networks. When we talk about topologies, we mean how networks are arranged. So how are networks connected? How is a host device connected to another host devices within a particular network or within an external network? How can you connect multiple host devices to a switch or to a hub? There is a point-to-point topology. When we talk about point-to-point, as the name signifies, two hosts connect directly to each other. The sending end of one host is connected to the receiving end of the other host. The sending end of one host is connected to the receiving end of the other host. In its simplest form, the two hosts are connected with a crossover cable. There are many types of cable. We have crossover cable, we have straight through cable. There are many types of cable. So when you are connecting, let me say, different devices, I think different devices, then you have to make use of straight through, but then same device, you have to make use of crossover cable. So that is point-to-point topology. Now, the star topology, hosts connect to the central device. That is the hub or the switch. The host connects to the central device. All the traffic flows through the central device. Let me come again. In a star topology, hosts connects to the central device. All the traffic flows through the central device. Style topology is also known as hub and spoke topology. Ethernet network. Remember, I mentioned Ethernet here. Whenever I mention Ethernet, understand Ethernet as wired connection. Ethernet networks using hubs or switches can pair through cable topologies. Ethernet networks using hubs or switches and twisted pair cabling are star topologies. I'm sorry for my ambiguous language. Now, the ring topology. In a ring topology, hosts are connected sequentially in a daisy chain, a sort of a chain, a screw fashion. Traffic flows around the ring. The last host is connected to the first host, thereby closing the ring. So they connect to each other as the sort of ring. And then the last host will now be connected to the end of the first host. And so they are connected to each other. That is a ring connection. So if you understand how ring looks like, you will know how what I'm actually talking about. Now for bus topology. In a bus topology, they are connected through a single cable using a coaxial cable. Now, most what do we call it? Most of these people, your GoTV, GoTV, DSTV, and so on and so forth, they make use of coaxial cable. So they majorly use this bus topology in a type of as a type of connection. So we also have mesh topology. In a mesh topology, multiple hosts are connected in a point to point in a mesh topology. They are connected point to point. These are multiple point to point connections that typically link every host in the network with every other host in the network. So point A connects to this point. Point A of this device connects to point A of this other device. Point B of this device connects to a point B of that particular of the other one. Point C connects to, so that is mesh. You are merging them together. That's mesh. Multiple connections, and they are connected according to point to point. So that is it for topologies of computer networks. So yeah, I don't know. What we are trying to enter now is the OSI reference model, which is very important that you all understand this. In fact, this is the bedrock of what you do in networking. So you have to know the layers of your network. There are 7 layers of network. So we have the OSI reference model, which has 7 layers. But then other people started founding their own networks. But OSI reference model is the globally recognized reference model of network connection of devices. So what I want to do is, before we move into the OSI reference model, based on what we have done so far, I will entertain 2 or 3 questions. I don't know if the moderator can permit me to take, if there are any questions based on what you have done before we move on this, maybe 2 to 3 questions on what you have done so far before we move to this one. And then just 2, 3 questions maximum, and then I answer it before we move to the OSI reference model. So I will be sure that at least we are done with this. And then when we are done with this, we'll now open general question and answer session. So just 3 questions and we are done with this. I don't know, the moderator, if that is okay by you, I'll be here to listen.
Yes, it's okay. It's okay. You can take questions.
Okay. So yeah, if there is anyone that wants to ask question, yeah.
There's a question on the meeting chat by Easy Ewe.
This question is not related to the topic, but yes, if you are in our platform, this question will be attended to at the end of the meeting.
Okay.
end of the class. Yes. So if you have any question, you can just raise your hand based on what we've talked on. The topic we've covered so far. Just raise your hand so we can trash it and then go ahead.
So if there are no questions, there are two implications. It's either that you understood everything I said without question, you understood it perfectly, or you did not understand it at all. So the people here, the people here in this call, which one is it? Is it that you understood everything I said, or you don't understand it at all? So I think there's someone raising his hand. I think Michael.
Someone just raised his hand. Okay, more people are
Michael.
coming up. All right, let me unmute Michael. Michael, I'll allow you to speak now, so we can go on with your question. They drop their hands. Okay. Wait, let me give them a few more minutes. Okay, so let me okay. Yeah. So Michael, you can talk or yeah, let's hear your question. Michael, you're on. Can we hear your question?
Michael, please unmute yourself. Unmute yourself so we can hear you.
I was asking
If you can hear us.
if we can get a PDF of the document.
Yeah, we can hear you now. We can hear you now. Please go on. I didn't get you. Please, can anyone else hear him? I don't know if he's
Yeah, I think his
network.
network is bad. His network is
Yeah.
bad. Maybe we'll move on to the next person. Person is ready. Michael, maybe you can try and
Michael.
rejoin. Your network is bad. Let me
Yeah,
quickly
I'll let
allow
her
the
when we
next
finish.
person. Yes. Just we
When we
have just one
finish, you
more
can ask.
person. Yes. Let me allow this next person.
Hello.
Yeah, Mike, are you on now?
Yes, I'm asking
Okay.
if we can Nini, I can get a PDF of the lectures.
Yes, you will get the video for the lectures. And
Okay,
it will
how can
also be on our YouTube channel. So when
okay.
you ready, our address us at the end of the class. Just hold on.
Uh-huh.
All right.
And then hello.
Go ahead, Michael. Go ahead.
Nini, I was asking if you can if Nini cybersecurity is related with PowerShell.
I didn't get you, please.
Sorry?
Pardon?
Hello.
Please come again.
I'm asking if PowerShell can assist much in cybersecurity.
If I get you clear, you said this PowerShell can assist in cybersecurity.
Yes, sir.
Okay,
PowerShell?
I don't think
Yeah,
Yes.
yeah.
that is related to what we have. But I can just say one or two things, Maurice. Let's move on.
You're talking about PowerShell. Yeah, PowerShell can actually help because the when you start doing let me say some installation or some remote configurations, you know, the PowerShell is PowerShell is let me say there is a name, PowerShell. I would advise making use of a Linux platform, Linux platforms for such. So PowerShell can help you, especially when you are talking about things like segmenting networks, things like Active Directory. You can make use of PowerShell. Yeah. But otherwise, Linux can do those things exhaustively. If you have ever heard of virtualization, have you ever heard of virtualization? Have you heard of it, Michael? Have you heard of it? Networking, virtualization. Okay. So if you have heard of virtualization, virtualization is the way that you make use of various operating systems. Instead of you buy a system that is Windows, you buy Linux, you buy Mac OS, you buy Chrome OS, you're even Windows Server, everything, you're buying everything, yeah, and so on and so forth. But you can just make use of virtualization and then virtualize these networks. And then you are using in the same computer, you have Linux, you have Windows Server, you have Windows client, you have Chrome, you have Linux, you have Mac, and so on and so forth. What you just need to do is PowerShell can help, but PowerShell is limited. That's the only thing I'm talking about. So that's it. I think when we are done, if I didn't clear you, we can talk about that more later when we are done with the lectures. So I don't know if Michael does not have any more questions. We'll move to Samsudin.
Yeah, let's move to Samsudin. Let me allow you to talk now, Samsudin. Yeah, Samsudin, you're on now. You can ask your question.
Can you hear me?
I can hear you.
Okay.
Yeah,
first of all, I want to appreciate the speaker. He actually spoke my mind concerning some of those things you have said, most especially the protocol, the network devices, and the rest like that. I highly enjoyed the presentation, but the only thing is that I think because of time, it was way too fast. But at least I enjoyed the presentation. So I would love that at the end of this class, the request session should be sent to the group so that we can listen to it over and over and over again. But in all, it was a good presentation. Thank you so much.
Okay.
All right. So Maurice, you can go ahead. Let's conclude.
Okay. Thank you, Samsudin. Yeah, thank you, Samsudin. I think when we are done, okay, the facilitator will have one or two to tell us concerning this. Okay, so please and also while we are a bit fast, okay, so just bear with us for now. Okay, so OSI reference model. I have told you that OSI reference model is the bedrock of networking. OSI reference model is the bedrock of networking. I have seen 3 persons go for an interview as network engineers. They just went there for internship. They were asked this OSI reference model. So it is very good that you understand the layers of network. You understand how these networks pass through from the first layer, from the upper layers, how the networks pass through the upper layers to the lower layers. So that is what we call the OSI reference model. Now, I told you that there are various reference model, just like you can come to, let me say, Android. And then in Android, you are going to see in Android, you will see various themes, various launchers. So these launchers, they have the same goal. Their goal is to do what? To beautify your phone and to make your phone to appear in a particular unique format. So there are many formats, there are many models, but this OSI is the one that was licensed and is the one that was sanctioned by the International Organization for Standardization, the ISO. So International Organization for Standardization is the body. They are the body that has it as a duty to sanction this reference model. And the goal of this reference model is to define the ways that networking devices connect and communicate within a network. So let me explain. I think when we are done with that, you're going to understand what I mean by reference model. The International Organization for Standardization defined the open system interconnection. They defined the open systems interconnection, which we call the OSI reference model, to standardize the networking of devices from different vendors. They defined this model to standardize the networking of devices from different vendors. It is not one vendor that sponsors networking devices. It is not one of them that patronizes the networking of devices. We have companies like Cisco and so on and so forth. So there should be a standard. There should be a standard that networking devices follow in a bid to do what? To communicate with each other in a particular network or within an external network. If company A comes and builds, okay, maybe where this one wants to connect, it will send this one to this one. It will send this one to point C, and then point C will send to point B, and then another company will come and then say, okay, their own is from point D, and then it sends to point F. You see that there will be confusion. So they want it to be, they define the OSI model as a blueprint, an architectural blueprint that networking and computer device manufacturers implement. So if you are a manufacturer of networking devices or computer devices, or devices that you want to communicate within a network, and then it does not meet this particular blueprint, then it will not be sanctioned and they will penalize you. Let me give you an instance. Have you asked yourself why all of a sudden iPhone 15 changed their charging port from their own normal charging port, their own unique charging port, to the global Type-C charging port? It is because the IEEE, which is the Institute of Electronics and Electrical they defined the blueprint that every charger should follow. So if Apple as a company is under this particular organization, is under this particular enterprise. So Apple cannot just come, any company, you cannot just come and build anything. It must be in line with this particular format. So that is the open system interconnection reference model. We have the TCP/IP, transmission control protocol / internet protocol, which is the closest implementation of the OSI reference model available today. So the TCP/IP out of carved out their own reference model from this OSI reference model. So let's progress. Let's talk about the 7 layers. Now, this OSI reference model has 7 functional layers. Each layer has a precise mission and works independently of the upper and lower layers. Upper layers use the services the lower layers provide, but each layer's internal workings are not visible to other layers, which means that every layer works independently. This independence is achieved through encapsulation. We call it data encapsulation, and very clearly defined interfaces between layers. Don't worry, I assure you that EmbodiLearn is out for you. By the time you are done with your program, you are going to understand what I mean by data encapsulation. That is a promise. So when I mention some of these terms, okay, you can just jot them down and then refer to them later. But I assure you that they are going to cover these topics. Okay. So the top layers build an application data payload. Still payload. So the data payload, an application, the top layers build an application data payload. There's something that we call a payload. So a payload is a body, a structure, the body, the entire body. So understand it as a data body divided by the lower transport layer. So the top layer, this application layer and the transport layer, they are the top layer. So when it comes to the transport layer, which is a layer, I think that is layer number 5 or so, it now has upper transport layer and lower transport layer that transfers or transports this data. So it is the transport data that collects this particular data in the top layers, okay, and then transports it to the lower layers. The top layers build an application data body or payload divided by the lower transport layer into several small data chunks. Thus, it splits it into small data so that it does not exceed the bandwidth like we mentioned before. So it splits it so that it splits it into segments. So each segment is numbered so that the receiving host can reassemble the application data. You know, when you are sending, just take for instance, WhatsApp. You remember that there was a time when WhatsApp was 30 seconds of status. You can only send 30 seconds, right? 30 seconds status, I think. And then they increased it to 1 minute. That's 60 seconds. So they have worked with 30 minutes and then they saw that they can actually work with 30 seconds because it is going to split each of these, because if it comes as a whole, if this data comes as a whole, then there will be a collision. So it has to split it, and then it splits it, and then numbers it. Okay, this segment is segment 1, segment 2, segment 3, and then when it reaches the receiving host will now do what? Will now reassemble it, and then you will now receive everything at once. The transport segments are then forwarded down to the network layer, which tags each segment with logical source and destination addresses and some control information, and hands them over to the shippable data packet to the lower data link layer. Don't worry, we are coming gradually. By the time we explain these 7 layers, I'm going to explain these 7 layers to you. When I explain it, you will understand the work of each of this layer as an independent and as a functional body. The data link layer adds the physical source address of the sender and the physical destination address of the receiver. If the receiver is located in the same network as the sender, let me come again. The data link layer adds the physical source address of the sender and the physical destination address of the receiver if the receiver is located in the same network as the sender. If the receiver is not located in the same network as the sender, the data link layer adds the physical destination address of the gateway What we call the gateway is the router. I know that some of you might have heard of router. So if a particular host will actually communicate, if it will communicate at all with another host in another network, it will do what? It will do what? Send it across to the switch, and then the switch will send it to the default gateway, which is the router. It is now the router that will communicate that information or that data to the other host in the other network. So without a router, a device cannot communicate with another device in another network. It can only communicate without a host can communicate with another host within the same network. But once it wants to communicate to another host in another network, it needs a router. The gateway of a local network is usually a router that connects the local network to other networks. Now let's start looking into these layers one by one. So we begin with the top layers. The first layer, the topmost layer, is the application layer, which is layer 7. This layer represents the various network applications, such as email readers, web browsers, HTTP that were mentioned in the beginning, file transfer protocol, which we mentioned, NFS, and so on. So it represents the application through which this communication, in fact, happens. The application layer provides a user interface and it processes network data. The application layer provides an interface. This application layer is the application, the place that the user sees what he or she is about to do. Like, this connection is actually happening, but the way, the medium through which the users make use of this network. Like, if other layers are just doing functioning, and then there is no user interface, there is no web browser where you can search for, where you can communicate with other networks, it doesn't make sense. If there are no email readers, like we have our Gmail, our Yahoo Mail, and so on and so forth, how can we then send mails? If there's no application for file transfer protocols and so on and so forth, then it doesn't make sense. So this application layer is the user interface through which this function is performed. The application layer on the sending host produces the network data to be transmitted from the sender host. Let me come again. The application layer on the sending host produces the network data to be transmitted from the sender host. That's the application layer that is from the client. Like I told you when we started, a client from your computer, you now type www.embodilearn.com, and then it will produce the network data to be transmitted to the sender. And then the sender, which is the EmbodiLearn's own server, will now do what? Consumes the network data. It will now do what? Will now process that particular request you made, and then do what? And then send back the required response. That is the function of the application layer. That's the topmost layer, 7. Layer 6, presentation layer. This layer is mostly concerned with data formats. It converts the data between different formats so that both the sender and the receiver can use heterogeneous data. For instance, mail messages contain various data formats: text, application attachments, video, audio, and graphical signature. Now, every type of data that you are sending in a network has its own format. That is what the presentation layer does. It is going to do what? Transform this data so that it references the particular data type that you want to do what? That you want to make use of. Every mail has its own type of data. Mails have their own type of data. That is why sometimes when you want to send a video or an audio through mail, it will tell you to do what? To send as an attachment. The presentation layer on the sending host receives the data payload. I told you, whenever you see payload, just understand it as a body. The presentation layer on the sending host receives the data payload from the application layer. So the application layer makes a request. What does the presentation layer do? The presentation layer will make sure that this particular data that the application layer is sending is in the specified format. So if it is not in that format, it will require the format or sometimes convert it into that particular format. If the application data is a mail, the presentation layer will do what? We transform it into a mail format. That is what this presentation layer does. The presentation layer on the sending host converts the data into a format that is easily transportable over the network. That's what I talked about. The presentation layer on the receiving host converts the data from the network format back to its native format that can easily be interpreted, used, and displayed by the application layer above. So as the application layer sends data, the presentation layer will do what? We check. Okay, is this format, is it in the correct format? Okay, let me convert it to the correct format. And when it reaches the what? The receiving host. Okay, when it reaches the receiving host, the presentation layer on this receiving host will do what? We also check whether it is in the correct format. If it is not in the correct format, it will also do what? Transform it. That is presentation layer 6, which has to do with data format. Session layer 5. Session layer, that is layer 5. Some applications need to open logical communication channels between computer hosts. Logical communication channels, which we call sessions, maintain data about the communication established between the network application running on the sending host and the network application running on the receiving host. See what happens when you register on a particular website, when you sign up on a particular platform. Do you know what happens? Immediately you sign up or register to a particular application, do you know what happens? That particular application opens a session with you. That session it is opening is that it has initiated a communication with you and it knows you. That session is on. That's why when you navigate to any other tab or even move out, once you are not logged out, because once you are logged out of that application, that session ends. But once you are logged in, that session is there. It is continuous once you are not logged out. So that session with you, anything that you do, you are logged in. Till you log out, the session ends. So that is what session layer does. Session layer opens and maintains logical communication channels between network application running on the sending host and network application running on the receiving host. It initiates, it opens a section, that is, it opens a communication between a sending host and the network application of the receiving host. Also, it handles authentication. Some network applications use authentication mechanisms before they open a logical communication channel with a remote host, which is what I just talked about. So when you visit some websites, it is going to ask you to register. That is authentication. Once you register, your data is saved, and then a session is opened until you log out and terminate the session by logging out. Then the session ends. That is session layer 5. Transport layer 4. That is layer 4. Transport layer manages transport of data between two hosts over a network. It makes sure that the data that is sent is received by the data that is sent is received by the host that is meant to receive it. So it is going to make sure that that data is received, irrespective of the medium through which it passes, but it makes sure that that data is received by the host that is meant to receive it. It slices the sent data to be transmitted into small chunks called data segments that can be easily sent over the network. I have told you that networks send data in chunks or segments. They don't send it as a whole so that it does not exceed the specified bandwidth. So that's why it slices it into segments. And then when it reaches the receiving host will now reassemble those segments, arrange them on the order that it was sent. So if you want to send a video of 15 MB, it is going to split it maybe into 2 MB and then attach some information we call headers. Those headers will have information about the type of data that is sent and so on and so forth, the size of it. It will now split it, and then it will now be sending it. The transport layer will now be sending it to 2 MB, to 2 MB, to 2 MB. When it reaches the receiving host, the transport layer on this receiving host will now reassemble everything together. That is the work of the transport layer. The network layer, which is layer number 3, this layer routes data packets across networks that link the sending and receiving host. This layer routes data packets. So now, when it is a network layer, we call these data packets. Know this as a tech person. Once it is in the network layer 3, we call the data packets. But once it is, in fact, once it is in from layer once from layer 7 coming down, we call it packets. But once it reaches the next layer, which we are going to talk about, which is data link, we call it frames. So know this: packets, frames, packets, frames. This layer routes, its duty is to provide the routes that the network will follow. The part or the route that what these packets will follow to reach the receiving host. So it will create a safe path between the sending host to the receiving host so that there will be no interference. It chooses the best route to send packets between hosts. Thus, it chooses the best route, which I just mentioned earlier, the safest route. That's when you do network, there is a shorter route, there is a long route, and so on and so forth. It will now say, okay, this type of data is this. Let me use this type of route so that it reaches, it takes longer time or it takes shorter time. Some data packets need longer time. Therefore, they need longer routes. Some others need shorter routes. It assigns logical addresses to all devices in the network to be able to identify host and each destination host, as well as each network through which packets need to be routed. Remember what I told you? When a host is communicating with a host on an external network, it needs IP address of both the sender and receiver. But if it's in the same network, it doesn't need what? It doesn't need a logical IP address. What it needs is a physical MAC address. We're going to learn this when the time comes. It receives each data segment from the transport layer on the sending host and wraps it in a data packet along with routing data. It receives each segment from the transport layer. Remember that segments are these chunks after they have been splitted, these chunks of data the divided data, the segmented data, okay, from the transport layer. So it receives this data and does what? And wraps it in a packet along with the routing data. So the routing data is the information about which route I should take. This packet is sent down to the data link layer to send it over the network's physical medium. So this received data, so what happens? The transport layer now sends these chunks of data to the network layer to do what? Okay, see this data that I have. Okay, look for the best route that you're going to take to send this down to the data link layer. That is what it does. On the receiving host, it unwraps the packet received to extract the data segment and sends it up to the transport layer. This is what happens on the receiving host. When it reaches the receiving host, it does what? It unwraps the packet that has been sent and extracts the segments of data and sends it up to the transport layer to do what? To rearrange it so that it will not be segments again. It is the work of transport layer to do what? To segment data and also to rearrange data. It is the duty of the data segment, so of the transport layer on the sending host to do what? To segment this data. It is also the duty of the transport layer on the receiving host to do what? Rearrange this data. Nota bene. Logical addresses are assigned at the network protocol level. I have mentioned this, and I will still mention it again. Logical addresses are assigned at the network protocol level. At this level, you need logical IP addresses. Physical addresses are assigned on the physical devices such as network card. We're going to look at that in the coming layers. Data link layer 2. The data link layer 2 transmits the data on the physical medium. It transmits the data on the physical medium. It routes the data locally on the physical medium. So if the data is if the data is between a host on the same network, okay, then this particular transmission will happen in this data link layer. But if it involves an external host, then it will push it up to the network layer, layer 3. It uses the physical addresses assigned to each. Remember, when I mention physical addresses, I mean the MAC addresses. So when I mention MAC addresses, it means that these hosts are on the same network device. They are on the same network, sorry. But when I talk about logical IP addresses, they are on a different network. It uses the physical addresses assigned to each physical network device in the local network to route data from one physical device to another. This is if they are on the same network. The data link layer receives each packet from the network layer on the sending host and wraps it in a data frame. Remember where I talked about packets and then frames. Now, in the data link layer, we are no longer talking about packets. We are talking about frames. The data link layer receives each packet from the network layer on the sending host and wraps it in a data frame along with the local routing data. The routing data is about the paths and all that it should take to reach the receiving host. The data link layer sends each frame down to the physical layer. I come again. The data link layer sends each data frame down to the physical layer, which is the next layer we'll talk about, and the last layer, the lowest layer. The data link layer sends each of these data frame down to this physical layer to code an electrical or optical signal to transmit the data frame over a wire or over the air. So when I talked about frame or when I talked about wired or wireless network, I told you that wired networks, we call it Ethernet. So Ethernet is when it reaches the data link layer, it will now say, okay, which medium do I use to send it to the physical layer? Okay, let me send it to the physical layer through which medium? Is it through a wireless medium or a wired medium? Is it wired connection or is it wireless connection? That is what is happening in this layer. Okay, how do I send it? How do I send it to this packet? How do I send it to the physical layer, which will now be either the wired or the wireless medium? On the receiving host, the data link layer unwraps the data frame received to extract the packet and send it to the network layer. Let me come again. On the receiving host, the data link layer unwraps the data frame received to extract the packet and send it to the network layer. So what happens if it will send the data to the network layer, okay, then it needs to convert it from a frame to a packet. This is what we call data encapsulation. So when you do data encapsulation, you're going to understand these terms I'm mentioning. So data encapsulation has to do with converting a particular type of data to an acceptable format. The network already knows that when it is a network layer, it is not expecting a data frame. It is expecting a data packet. So this is what happens. And the essence of the data link layer is to check, first of all, is this connection between hosts on the same network or between hosts on a different network? If it is between hosts on different networks, then it will ask for the logical IP address which has been sent by the network layer. If they are between hosts on the same network, it will ask for the physical MAC address. The last layer, which is layer number 1, is the physical layer. The physical layer provides the electrical, optical, or over-the-air connection between the sending host device and the receiving host device, which means it provides the physical medium, which I told you about, which can be wired or wireless medium. The physical layer defines mechanical, electrical, optical, radio procedural, and functional standards to enable transmission of data link layer 2 frames over a certain transmission medium. The physical layer defines the format, whether it is a mechanical format, an electrical format, an optical format. So when you these are all the things that you do in networking. So electrical format, even when you talk about the electrical format, these are the type of let me say the formats. You have radio waves, we have electrical format, we have mechanical, and so on and so forth, that the transmission will follow. So I don't know if I move into it now, it will be ambiguous for you people. So let me just leave it at this. These standards define how a physical link is built, activated, maintained, and deactivated to enable transmission between data terminal equipment and data communication equipment. Data terminal equipment are host devices, and data communication equipment are network devices. Remember what I told you about host devices and network devices. Any device that stands between two host devices, any device that connects two or more host devices is known as a network device. Any device that communicates, with another device is known as a host device. The benefits of OSI reference model. Independently operating layers with clearly defined interlayer interlayer interfaces allows layers to evolve internally without impact on other layers. So independently operating layers, the essence, well, I mentioned it earlier, that OSI reference model, okay, allows communication between these layers, but also it allows each layer to be independent in its workings. So they operate independently, but yet they communicate with each other. So independently operating layers with clearly defined interlayer interfaces allow layers to evolve internally without impact on other layers. So each layer can do what? Can evolve, can upgrade, can update on its own without affecting any other layer. That is the benefits of this OSI reference model, which allows for what? Independence of layers. Network communication problem is divided into smaller problems, ensuring easier management. Therefore, if a problem ensues, it will now be traced according to which layer is not functioning properly or which layer did not perform its function, and then it will help to manage this particular problem and then curtail it. A network reference model provides a blueprint for all manufacturers, ensuring compatibility of varied devices from various manufacturers. So now there is a blueprint. Every manufacturer will know that this is the particular blueprint that I should use when manufacturing any network device or any host device, any computer device. So that every network device or every computer device will now be compatible irrespective of the manufacturer. So these are the benefits of the OSI reference model. So with this, we come to the end of what we are supposed to learn in this masterclass. I believe that we have learned a lot for today. And as we go on, I also believe that EmbodiLearn will be able to provide us with the necessary materials that we need to be effective cybersecurity persons. Thank you.
Ladies and gentlemen, that concludes Maurice's insightful presentation on introduction to networking in cybersecurity. I would like to extend my sincerest gratitude to Maurice for sharing his expertise with us today. Your knowledge and passion for cybersecurity are truly appreciated. So now it's time for Q&A. If there's any question, the floor is open and we have a few minutes for questions. So I'll appreciate if we start now. If there's any question, we can raise our hand or drop it in the meeting chat.
All right, someone is asking from Samsudin, say they have read the OSI model many times, most especially during my MXC program and my CCNA training, but the presentation here gave me up expectation about how it works. Thank you so much. Thank you so much, Samsudin. Expect more of this from EmbodiLearn. So Chris Pinus is asking for a LinkedIn profile. Okay, we'll handle that in a moment. All right, let me take a few minutes and talk to us. So for some of us that are on this call, those of us from Kenya, and those of us from Nigeria, welcome you to this important session. So I just want to give us a bit introduction about EmbodiLearn and what we offer to our students. I'll be sharing my screen in a few minutes. And okay, so EmbodiLearn is a company. We offer training in cybersecurity and other aspects of IT. And for our cybersecurity training, We offer it in partnership with CompTIA, and we also prepare our students to sit for CompTIA Security Plus certification, which is like the minimum professional requirement for most entry-level cybersecurity jobs right now. So in addition to that, we offer you the CompTIA security training. So some of us will ask, why cybersecurity? So cybersecurity is a very important skill right now. And we notice that most companies spend more trying to protect themselves from cyber crimes that they will actually spend in employing a cybersecurity professional. So cybersecurity matters, and that's why everywhere we're talking about cybersecurity right now. So why choose EmbodiLearn? EmbodiLearn, we are globally accredited by the American Council of Training. We're also accredited by the UK government through the UK PRN. We are partnered with CompTIA and other industry leaders. We offer hands-on training, real-world simulations, and case studies. We also have expert instructors like what you've learned today. And in addition, we offer flexible learning. We have online classes that fit your schedule, no matter which country you're learning from. The course at EmbodiLearn is a 12-week course, and you will be covering every aspect of cybersecurity, ranging from threat management, risk mitigation, vulnerabilities and compliance, network security, like we've learned today. And in addition, we offer you a certification in CompTIA Security Plus. Now, why CompTIA Security Plus? I may not go into all the details, but we know that it's an industry standard for core security skills. It's approved by the US Department of Defense, and it paves the way for jobs like security administrator, system administrator, and many more. Within the Security Plus, you learn things like risk management, cryptography, and security architecture. So for some of us that are on this call that are really IT professionals, perhaps you wouldn't want to just start becoming a security, cybersecurity professional. Maybe you want to gain 1 or 2 certifications in CompTIA. As a CompTIA partner, we offer 10% discount on all CompTIA certifications. Visit a CompTIA Security Plus, CompTIA Security Analyst, CompTIA Pen Test Plus, CompTIA Advanced Security Practitioner, Cloud Plus, Linux Plus, and Network Plus. All CompTIA certifications, you get it at a 10% discount via EmbodiLearn. While this offer valid till December 31st of this year, we'll be offering it for some time now. But after that, we'll also review and come out with a better offer if possible. But we are always available to serve you. Now, for our cybersecurity training, we are offering a 30% discount. Initially, the training goes for 150,000, but within the course of this discount, we'll be giving out 105,000. So if you want to learn more about cybersecurity, you want to know how to protect networks that we've learned today, this is your time to get this training and start your career as a cybersecurity professional. So yeah, so how do you enroll? Our website is at www.app.embodilearn.com. Once you log on to our website, you select cybersecurity and pay the application fee. Once you pay the application fee, you send a message to this number on WhatsApp. It's going to give you a coupon to complete your enrollment, because the price you're going to be seeing on the platform is 150,000, but we're going to give you a coupon to reduce the price to 105,000. So that's basically all for EmbodiLearn, and we are fully ready to make your journey in cybersecurity a very fruitful one. And of course, after this call, we will request to send the recordings to us. After this call, you will be receiving some emails to that regard, and that will include the recordings. And someone will also chat you up on WhatsApp to continue the conversation on how to enroll. So I'll be dropping the phone number on the Q&A session, so you can quickly copy the phone number and chat us up on WhatsApp to continue the conversation on how to start your career in cybersecurity. So I don't know if you have any other question before we finally call it a wrap. So I'll also be sharing our LinkedIn profile. Let me share it on the Q&A session now, so you can connect with us on LinkedIn. Let me share our LinkedIn profile on the chat box now. Give me a few minutes. LinkedIn profile EmbodiLearn. So you connect with us. We are also on Instagram. We are also on Facebook. Just EmbodiLearn. Simple. Find us on social media. Follow us to find out more about our package, our courses, and what we have for the general public. Now, also note that this masterclass is a recurring program. Starting from January, this will be held once every week. And we already have your emails, and we'll be sending you details of any further masterclass that we have. So kindly always join to learn more about IT, about cybersecurity, and as you continue to grow in your various careers. So yeah, so I think that will be all from my end. If you have any question about the trainings or what we've talked about today, you can go ahead and ask. So over to you, the moderator.
Okay, we thank our host for the beautiful presentation and awareness on how to enroll and every details. We really appreciate. We're still waiting for questions. If there are any questions, it's still time to bring your questions as we'll be closing shortly after. But if there are no questions, we'll call it a day.
Sorry, Michael raised his hands. Let me allow him to ask a question. Michael, you
Okay.
can mute yourself, okay?
A few minutes ago, you talked about something compared to Windows PowerShell. Can you remind me the name of the software?
Okay, Maurice, I think you talked about something. Just can you refresh him on what we talked about the PowerShell and all that? Just briefly before.
Okay, yeah. I mentioned virtualization. VIR. Let me just type it in the Q&A. So is a process, okay, and where you can like visualization. So there are some software that you can make use of. One is VMware.
I can't hear you.
VMware.
Maurice, your network is breaking bad. Can hear me, maybe you can.
VMware, very good. And I've forgotten the name of the other one. I think I'm just give a second, please. I don't know the name. And please, can you hear me? Oh, can you hear me now?
Really. No.
Hello. Network.
Your network is breaking. Your network is breaking. We can't hear you clearly.
Can you hear me now?
Yes, it's better.
Okay. So I talked about VMware. VMware is good. Very okay. VMware is very okay. Then you can just use it. It's very easy to use. Very easy to use. Just type of VMware, and then you're good to go. And then what happens now is that because VirtualBox, very good. Thank you. VirtualBox, yeah. So we call it VirtualBoxes, visualization. So but there are some VirtualBoxes, VMware. I make use of VMware, which is very okay to me. And yeah. So you can, what happens is that you can download an operating system, you see that you download the ISO file. So when you install the ISO file, then you can now download the ISO file and install it. So with that, you can run multiple operating system or multiple programs. So as a cybersecurity person, you will be running Windows Server. You will need to run Windows Server because what every other person uses is Windows Client. So you need to make use of Windows Server. I think I'm using 2019. 2019 is okay. There's 2016. Just download the ISO file. You can go to your browser, download it. And then even if it's Linux that you want, Ubuntu, Kali Linux, and so on and so forth, all those ones, you can download any distro of Linux you want. So with VMware, you can be running it. So that's what we use for that. Otherwise, for Windows, what PowerShell offers is actually, I would say that for cybersecurity, you need Linux. You need Linux, honestly. PowerShell is limited once it has to do with this. So, but with Linux, you will perform more than what PowerShell offers you. Thank you.
Okay, thank you. I don't know if your question is answered.
So that means when I try using PowerShell, I'll be restricted to some commands.
Yeah, the thing is, you actually know that let me see, the reason why people started talking about virtualization, especially that cybersecurity personnel, on the part of let me say, PowerShell was built for Windows users. You already know that it was built for Windows users. And then if you want to make use of, let me say, Linux commands, because PowerShell has its own commands. But if you want to make use of Linux commands, then you have to install Bash. You have to install Bash. So it is Bash that allows you to use a command line interface that is of Linux. So Linux has more, like, if you're going to focus on things like pen testing, not just even pen testing, if you're going to focus on other parts, when you move into cybersecurity as a whole, you will need some distros of Linux and you will need to know Linux commands because Linux is more broad. The commands is more broad. Like the commands that you will use to PowerShell has its own commands. I'm not saying that it does not have its own commands, but running some global commands and all that, you have to run those Linux commands. That's why you have to run Linux as a software on your system. PowerShell is limited to me. From my experience, PowerShell is limited to me. PowerShell is good, but I prefer this one because Linux is more broad and more sophisticated.
Okay, thank you.
Okay, we thank our guest speaker for the answer. With this, we will come to the end of this webinar. And we appreciate everyone for staying with us up to this moment. We hope to see you in our next webinar. With this, have a very nice evening. Thank you.